All right, the sides of an equilateral triangle are increasing at a rate of 22 millimeters per minute. How fast is the area changing when x is 11 millimeters? All right, first thing that we're going to need is to think about that equilateral triangle. We want to find out how fast the area is changing, so I need an equation for the area. Now, we had spent some time, just a little bit of time, looking at this equilateral triangle. If all sides are equal and equal to x, then, and we cut this triangle in half, the base of this triangle would be 1/2 of x. And we have a 30, 60, 90 triangle, so the height of this triangle is going to be the square root of 3 over 2x. Meaning area is 1/2 of the entire base, the whole base was x, times the height. Meaning that area can be simplified to square root of 3 over 4 times x squared. Now, we've developed this formula a couple times. What I've been telling you is that I want you to just know that that coefficient is going to be square root of 3 over 4. Of course, if this were on the test, I would probably give you that formula or make you derive that formula somewhere else on the test. Anyway, what we want to do is to find out how fast the area is changing. So that means I need the rate of change in the area. So we take the differential of area with respect to time, so that would be the derivative. And we take the derivative of the other side then too. When I bring down the 2 for the power rule, we'll have the square root of 3 over 2 times x dx dt. Now we plug in all the information that we know. We know that the sides of an equilateral triangle are increasing at this rate. What that means for us is that the side was x, and the rate of change would be dx dt. Since it's increasing, it's positive, and its value would be 22 millimeters per minute. So I'll plug that in for dx dt, 22. The other thing we want to know is when x is 11. So I'll just plug that in for x. And the only variable we have left then is dA dt, how fast the area is changing. So a little bit of canceling here. We should get an answer of 121 square root of 3, and we need to include units. We can go back and think about our variable here, dA dt. That's a change in area. Area is measured in millimeters squared. With respect to time, in this case, time is measured in minutes. So there's our solution.